Okay, guys, good morning. So for science today, you guys, we're going to look at it's the law of conservation of energy. And I posted a video in there. So you'll watch the video, and then there are some questions that you have to answer. And the questions are all right here. I think there's 8 or 9 of them, five of them, excuse me. And it's all about potential energy. So you can go back and watch that afterwards and go ahead and answer the questions. And then what this asks you to do is you're going to create an experiment. Um, and I did cover this in class. Basically, when you do any type of experiment, it's called the scientific method. And I'm just going to go over the parts of it. The first thing you do is make an observation. Okay. I think in class I talked about if your car won't start. Okay. So you have to make an observation. What's wrong with my car? Okay. Obviously, you know it's not going to start, but then you have to basically figure out why it won't start. And then what you do is you construct a hypothesis. What is the question you would like to answer? So maybe you're going to say it's out of gas. Maybe you're going to say the battery's dead. Maybe you're going to say the alternator's shot. You make your hypothesis as to why your car isn't starting. Okay. Then the next step in the scientific observation is you test that. Okay, so if you say you're out of gas, you put gas in your car. Okay. And then you're going to see if your car starts, and that would be analyze data, draw a conclusion. If you put gas in there and it starts, well, you've solved your problem. You realize, oh, it was out of gas. But if you put gas in it and it doesn't start, you're like, well, that wasn't the problem. It's not the gasoline. Okay. And then the last thing you would do is you accept or reject your hypothesis. So if you put gas in there and it starts, well, I accept my hypothesis. That's what it was. But if you put gasoline in there and it doesn't start, you're probably going to reject your hypothesis and you go back to the drawing board. And then the last one is you were to report your results. So you'd say, I put gasoline in the car and it didn't start, or I put gasoline in and it did start. And that what you just did there was the scientific method. So you make an observation. Okay, then you construct a hypothesis. Then the third thing is you test your hypothesis. Then you analyze your data. I put a gallon of gasoline in my car, 2 gallons of gasoline, and it started or didn't start. And that basically, based on that, you're going to have an idea of whether your hypothesis worked or not. And then the next step, it did. Gasoline solved my problem. My car turned over and started, or even though I put gasoline in there, the car still won't start. And then the last step is you just report your results. Okay, so that's a scientific method. And up here, it asks you would have done something with like a pendulum, similar to what the video did. It asks you to kind of do your own experiment. Okay. So, and here is basically the answers, the steps of scientific method. So you make an observation, construct a hypothesis, test the hypothesis, analyze the data, acceptors, reject, and report results. And up above in the reading, the scientific experiment was on, I think, doing a pendulum here. And I think the video was about a pendulum. I just want to do the car because I think that's a little easier for you guys to understand. But if you read through this, it basically talks about you guys constructing like a pendulum. And a pendulum is just basically a piece of string with a weight on it, swings back and forth, okay? So right down here, I'm going to get to the conservation of energy. Okay, and this says energy everywhere. Wherever you look, you see the effects of energy. Cars moving, kids playing, water boiling, all depend on some form of energy. Energy is very important to life in our society. What is energy? Energy and matter are basic parts of the universe. Matter is anything that takes up place and has mass. Energy has the ability to work. Work happens when a force moves an object in the direction of that force. Energy and work are measured using the same unit, and that's called the joule. So energy exists in many forms. Electrical energy is used in homes and workplaces. Many machines change electrical energy and energy needed to do work. Energy changes also play an important role in nature. Plants use energy from the sun to grow. The energy we get in our food comes from energy stored in plants or animals that ate the plants. Changes in energy are also important. Energy changes follow the law of conservation of energy. It has two parts. The amount of energy in a closed system always stays the same. Energy change forms, but it cannot be created or destroyed. In every energy transformation, some energy is lost to friction or changed to thermal or heat energy. The energy still exists, but is not used to do work. Okay, so here are two types of energy, potential and kinetic energy. So changes in energy involves potential energy and kinetic energy. Potential energy is stored energy. Kinetic energy is the energy of motion. Anything that is moving has kinetic energy. Thermal, electricity, sound energy also have kinetic energy. So it says energy is constantly changing from potential to kinetic and back again. These back and forth can be seen in your body's motion, in your muscle. Your body stores chemical potential energy from the food you eat. When you need your muscles to throw a ball, your body changes some form of that chemical potential energy to mechanical kinetic energy, the energy of your moving arm. Another example is electric toothbrush has chemical potential energy in it, in its battery. Potential energy changes the battery, then mechanical and kinetic energy. Anything that can be bent or squeezed, then returned to a natural shape, or anything that's flexible, such as a rubber band, has elastic potential energy. Think about some other common examples of energy use: a bow and arrow, a wind-up toy with a spring, a car engine powered by gasoline. Think about the forms of energy used. Now we get on nuclear energy. It says nuclear energy is the most powerful form of energy. It is released in a nuclear reaction. In this reaction, nuclei of atoms of one element are changed to nuclei of atoms of a different element. Nuclear reactions occur in nature. The sun and other stars are powered by a nuclear reaction called fusion. In fusion reaction, a small nuclei join together to form a new nuclei. Extreme temperatures and pressures in the core of stars enable fusion reactions. Large amounts of energy are released in this process. Nuclear power plants use another type of nuclear reaction called fission. Fission involves splitting nuclei of the elements uranium and plutonium to release energy. The heat that results from fission in a nuclear power plant is turned water into steam, which is then used to make electricity. So a nuclear power plant, it has like a rod going up in the middle of it, and there's all these atoms basically flying around, and those atoms split, and that creates energy. And that energy, like it says, heats water to create steam, and that steam we use for energy. And it says nuclei are made up of protons and neutrons, but the mass of a nucleus is less than the sum of the masses of protons and neutrons. The difference in masses represent that energy holds the nucleus together. In the nuclear reaction, the energy is released. So you can kind of see this here. Everything is bouncing around, and then they hit that rod and they split. Okay, and that's kind of a form of energy when they start splitting. Okay. So this goes back to the reading. What is conservation energy? So the second part of the law of conservation energy is energy can change forms, but it cannot be, you go up here, so it says it cannot be created or destroyed. So energy basically is always waiting there. You know, that would be potential energy. Okay, but it can't be destroyed. Okay, so that first one, it can't be destroyed. Moving objects, thermal energy, electricity, and sound energy have what type of energy? So we go up here. That would be potential energy. Okay, because the energy is always there. Chemical compounds an object lifted up a rubber band muscles have, that would be kinetic energy. Moving objects, hold on, went one too far there. Let's go back to number 2 here. Moving objects, thermal energy, electricity, and sound energy have that would be kinetic, and the third one is potential. So 2 is kinetic and 3 is potential. Okay. This one says when nuclear atoms of one element change to a different element, that would be nuclear energy is released. And that would be so nuclear energy is the most powerful form of energy. Is released in nuclear reaction. This reaction, nuclear atoms, one element change to nuclear atoms, a different element. So nuclear reactions occur in nature. So that would be nuclear. Okay. Then 5, it just asks you to fill in the blanks here. And you're just going to take examples. So a rubber band and a toy airplane unwinds, you throw a ball, you flip a switch, an electrical toothbrush. Those are all in the reading right there. And number 8, it asks you to give the main idea, describe some properties of energy. Vocabulary, explain the difference between potential and kinetic energy, give examples how it could transform the other, and describe how the Earth would be affected if no longer got energy from the sun. Would be really cool. Okay. And 11, a kitchen blender transforms electrical energy into mechanical energy. Why is the amount of mechanical energy produced less than the amount of electrical energy used? Okay. And number 12, it says nuclear fission and nuclear fission both release huge amounts of energy. How are the processes different? Okay. And this one asks, which of the following prescribed as kinetic energy? Okay. So right here are all the answers. So if you're basically want to go back and check to make sure that you got them right, you can just look at the teacher key right here, okay? And like I said, you're just going to basically go up and everything is in this short reading right here, okay? So I'm going to do social studies here in about 15 minutes. Remember that the video is listed in Google Classroom, and the video you're going to watch, you're going to answer these 5 questions right here. I think the video is only 3 or 4 minutes, so it's really short. So you can watch the video, and then the questions are right there, and the answers are right here. Okay, so if you don't get, if you're not sure about an answer in the video, you can check your answers right here. Okay, guys, have a wonderful day, and hopefully I'll see you for social studies.